Hi everyone, welcome back to the to our second part of Siloxane's webinar. Welcome to those who joined us last week, and then also welcome to those who are our first-time participants. This will be part 2 of our 3-part series on Siloxanes hosted by ALS Environmental. A couple of housekeeping items. Again, this is a webinar series. This will be part 2 of 3. Part 3 will be held a week from today, which is Wednesday, May 28th. Each webinar will be approximately 20 to 30 minutes long. This webinar will be recorded. Upon completion of the series, the full webinars will be archived on our website at alsglobal.com. And then the last thing is participation. Please ask questions using the GoToWebinar system to type in any questions you might have. We plan on having a pretty in-depth webinar this afternoon, and it's going to be on Siloxane, so we expect some great questions from the audience. And with that, I'd like to welcome back Samantha Henningsen. Sam is our project manager here at the Simi Valley Laboratory. She's also a chemical engineer, and she has a tremendous amount of experience with air projects, including Siloxane. So with that, Sam, take it over.
Thank you, Edwin. Again, my name is Sam Henningsen, and I will be presenting the second installment of the ALS educational webinar series on Siloxanes, Siloxane Regulations and Commercial Analyses. Just as a brief overview of what I'm going to go over today, I'm going to, again, like last week, go into the Simi Valley Air Quality Laboratory, give you a brief overview. I'll give you a brief overview of Webinar 1 from last week, Siloxanes, what are they? I'm going to go into state and federal oversight for siloxanes, as well as commercially available methods. I have 2 case studies to present to you, and then at the end we will leave time for a summary and some questions. As far as ALS Simi Valley is concerned, we're a 20,000 square foot facility located in Simi Valley, California. Some of you might previously have known us as Columbia Analytical Services, but we now operate under ALS Environmental. And this particular location specializes in air analyses. While we have a number of different services and markets that we support, this presentation will focus mostly on landfill gas and our areas of expertise. This will include things like permitting and compliance, energy content, gas composition, as well as odor and nuisance testing. As far as our siloxane method, we brought it online in 2011, which I'll talk about a little bit more later in this presentation. But in essence, we had identified a client need, and so through method and development, we brought this method online. So last week we talked about siloxanes. What are they? We went into the basic chemistry of siloxanes. We went into the idea of combustion, how the siloxanes convert into silica in the presence of oxygen and heat. We talked about how the silica deposits on our turbines, microturbines. I have a list of commonly affected equipment up there, as you can see, as well as typical physical symptoms that you'll see of siloxane damage. And we also talked about where the siloxanes come from, anywhere from your personal hygiene products to your oils and lubricants, and even to your fried foods and your low-fat alternative foods. So let's jump in. Current regulations. Now, I hope I wasn't pulling your leg, but unfortunately there are no current state or federally regulated methods. As far as federal and state oversight, normally the regulations are usually dictated by human health standards or environmental action limits, and unfortunately siloxanes don't usually fall under those categories. They're more manufacturer nuisance rather than actually hazardous to the environment or hazardous to people. There is an ASTM task group that has been put in place to create a method for analyzing for siloxanes and biogas, and word on the street is that it would probably be promulgated in 2015. So I would hopefully look out for that. But in the meantime, there are a number of commercially available methods, and we will plan on going through them right now. Just as a brief overview of the methods that I'm going to go into, the methods are really going to be separated by collection device. Now, as you can see, the sorbent tube, which is in your top left-hand corner, that's what ALS uses, and that's the method that we service here, but there are also a number of other methods available. There's sampling collection using things like a Tedlar bag and a Suma canister. Those would be where you're actually collecting physical air. There's also mineral oil as well as methanol in pinchers. So this is kind of a picture of what you might be collecting your siloxane samples in. When you're comparing sampling concerns, I've created this table which outlines a number of different concerns that you might have when you're out in the field sampling under 3 basic categories. You have A, your Tedlar bag and Suma canister. Those would fall under what I call whole air sampling the air, and you're sending a sample of that air to the lab for analysis. There's also sorbent tubes. Now, sorbent tubes are collected by passing air through a tube filled with some sort of sorbent media. In our case, it's a treated carbon bed, and the siloxanes will actually adsorb to the solid sorbent material inside. And the final collection method is an impinger or some kind of bubbler, where you're actually physically bubbling the air sample through a solution, and the solution is absorbing the siloxane compounds. As far as sampling time is concerned, it's broken down into 2 basic, less than a minute. At the laboratory. In this case, it's between 30 minutes to 3 hours. You know, the training time that it takes to train a sampler, the time it takes to actually physically sample, if there's a temperature requirement, how heavy the box is, if it's easy to ship. You know, that would all fall under ease of use. And as far as Tedlar bags and Suma canisters are concerned, they're relatively easy to sample. And the mineral oil and sorbent tube are medium because it does take some sampling time to get it set up, and they don't have to do hazardous shipping. And then the methanol impinger is considered to be difficult. Now, the final thing to note is the Department of Transportation hazardous shipping. Now, I don't want to leave this slide without making note that if you are shipping a landfill gas sample, especially if it's a whole air sample, like with a Tedlar bag or Suma canister, you will have to comply with the Department of Transportation hazardous shipping requirements. And that being said, if you're shipping landfill gas, which contains normally is flammable, and so it needs to follow the limits, as well as H2S, which is considered to be toxic. So that's something that you'll want to keep. The reason the methanol impinger samples would need to be shipped hazardous is because methanol is a toxic substance. As far as the sorbent tube and the mineral oil are concerned, they do not need to comply with these, with these hazardous shipping requirements because the methane and the H2S pass directly through, and the sorbent and mineral oil are non-toxic. As far as comparing analytical concerns, I went ahead and I noted all the methods as well as the compound lists and the approximate reporting limits. Now, every method has a slightly different reporting list, anywhere from total mass of silicon to a 10 compound list. And you know, some methodologies I've seen do as many as 22 siloxane compounds. But the thing to really keep in mind is these approximate milligrams of silicon per meter cubed reporting limits. Now, the approximate reporting limits in ppm of D4, because D4 is the most common siloxane found in landfill gas. And the thing to note is if you compare the approximate milligrams of silicon per meter cubed values at the top with the siloxane limits for typical engines, turbines, and microturbines at the bottom, you'll see that some of these limits are actually lower than what some of these methodologies can supply. So even though you might get a report from a client or from a laboratory that says that the values are non-detect, that doesn't necessarily mean that there aren't any siloxanes. It just means that they're lower than the limits of detection can reach. So that's something that you're always going to want to keep in mind when you're speccing out not only your equipment but also the laboratory that you're planning on using. So just as a basic comparison summary, impingers are relatively difficult to sample and ship. They require hazardous shipping and coolers. However, they do have moderate reporting limits. The sorbent tubes are moderate to sample, easy to ship, and they don't need to have hazardous shipping or a cooler, and they have low reporting limits. The mineral oil is moderate to relatively easy to sample. They're heavy boxes to ship, They don't require hazardous shipping or a cooler, but they have high reporting limits. The Tedlar bags are easy to sample and lightweight to ship. However, they do need hazardous shipping, a cooler, and moderate reporting limits. And the Suma canister is easy to sample, heavy to ship, and it also requires hazardous shipping requirements. However, it has moderate to low reporting limits. So moving on to the data comparison and case studies. The first case study I'm going to go into was actually the ALS method development, which was a study led in 2011. When we were first bringing this method online, we tried a variety of different sampling protocols and collection devices in order to optimize the method that we were planning on marketing to our clients. So in 2011, we decided to do some field samples. We conducted the field samples at a local landfill where they currently flare 80% of their gas, and they send the remaining 20% through a condenser and into a small gas-to-energy facility. As far as our field samples are concerned, we collected only raw, untreated landfill gas, and we collected them using canisters, the sorbent tubes that we utilize now, as well as impingers. The first data set I'm going to show you is actually the siloxane recoveries. Now, the landfill did not want us to share the actual physical data with you, so rather than telling you the actual concentrations of siloxanes, I created a concentration ratio, which is based off of the largest recovery, which looks like it was the impinger for D4. Now, as you can see from these siloxane recoveries, trimethylsilanol D4 and D5 are the largest values out of all of the siloxanes that we had analyzed. It actually comes out to about 78% of the total mass. And L3, L4, and L5 are relatively insignificant. They actually made up less than 2% of the overall mass. For the results with the canisters, as you can see with the red arrows and the blue bars, the values look relatively low, not only compared to every other method, but also compared to the average. So that was one of the reasons why we ended up not going with a canister, was because it looked like it appeared to us that the results were all biased low. As far as the impinger is concerned, for D4 and D5, it was extremely relative. It was definitely very comparable. However, considering trimethylsilanol composed 33% of the overall mass that we found, and the impinger, in essence, can't analyze for alcohols because you can't analyze for an alcohol in an alcohol, it ended up missing quite a bit of the overall mass. The sorbent tube, which was able to accurately quantify all of the siloxane compounds that we were looking for, as well as had a median range recovery for all of the compounds, we found that to be the best method relative to what we were looking at. And you can also see that the standard deviation between the total mass average and the sorbent did not vary by more than 5%. So by any typical QC protocol, that would have been considered applicable and acceptable. The second graph I'm going to show you is actually the percentage recovery comparison. So in essence, what happened was I picked the baseline of the sorbent tube to be a ratio of 1, and I compared the recoveries of all of the other siloxane compounds to the sorbent tube to see how the methods performed with each other. In essence, this graph doesn't necessarily take into account the abundance of certain compounds, but rather the ratio of their recoveries compared to the other methods. So, for instance, if you look at the first column, canister and trimethylsilanol, it says 0.48. That means that the recovery was 48% as compared to the sorbent tube, which is 1. Again, overall, the canister underperformed as compared to both the sorbent tube and the impinger. And while the impinger was definitely extremely comparable to the sorbent tube, it still missed out on trimethylsilanol. So ultimately, our conclusions to the case study were D4, D5, and trimethylsilanol were the primary siloxanes of concern. And then ultimately, while this case study was interesting, our overall goal was to figure out which collection device we wanted to utilize. So we ended up going with the sorbent tube because A, it was the most comprehensive of the list, as well as it had higher overall recoveries as compared to the other methodologies we compared. Moving on to case study number 2. So this was actually a client-collected sample. Our end client was an operator at a landfill in Oregon, and They took landfill gas samples to support an agreement with Caterpillar Financing. As far as the samples that they actually took, they collected and shipped mineral oil samples. So when they got the results back, the siloxane results were actually 0.6 micrograms per BTU. They did not notice any sort of physical or visual damage to their engines, and the values were actually 6 times greater than the recommended Caterpillar limit. So in response to that, they decided to run a comparison of 3 methods to see how comparable they were, not only to the mineral oil, but also to each other. So they ended up taking 2 of our sorbent tubes, an additional mineral oil sample, as well as 2 Tedlar bag samples, and they sent them all to different laboratories for analysis. As far as the results are concerned, the table up above just shows, some of the variability between the methods. They all utilize different analytical instruments, they all utilize a different compound list, and then they all have slightly different results. So as far as the results column in the table, it's all related back to the mineral oil values because that's what the client was comparing against. And as you can see in the table, the Tedlar bag and sorbent tube are actually over 80% less as far as the final result than the mineral oil sample. And as far as the 80% less value is concerned, if you look at the graph below, the Tedlar bag and sorbent tube are both below the Caterpillar limit, which validity, it adds validity to the fact that there were no physical or visual damage to the engine. And that leads to the conclusion that the mineral oil results appeared to be biased high as compared to the other 2 results, which they compared within 5%. So within any typical criteria, that would be considered to be comparable results. So why is there variance among methods? What are some potential reasons why there might be variance? And unfortunately, there are a number of vast different reasons why the methods might not match, anywhere from the sampling media. I just spoke about 5 different collection devices today, but there are many more. I've heard of real-time samplers and all sorts of different sorbent tubes, and there's a number of different sampling media, and all of these media are optimized to collect samples a little differently and optimized to collect certain samples better. They might adhere cyclical siloxanes better than the branch chain, and so these are all fairly different as far as sampling collection is concerned, as well as analytical instrumentation. The analytical instrumentation will all be slightly varied to optimize in different ways. Labs might use different calibration standards or target analyte lists. The reporting limits, as I went over, were all fairly different. Again, just because you get a value that says ND, it doesn't necessarily mean that the siloxane is not present. It just means it's not present at that limit. And then finally, the results calculations and reporting format. Now, you want to make sure that you're not comparing value as milligram of silicone per meter cubed of methane. And so you want to make sure that the values that your dealers are giving you and that your engine is spec'd out for are actually the units that you're utilizing at the laboratory and that you're comparing against so that you get accurate readings and accurate values. So as a basic conclusion of what I went over today, I talked about the Simi Valley Air Quality Lab. I did a review of the first webinar, Siloxanes, What Are They? We went into regulations as well as commercially available methods, and then we talked about 2 case studies, an internal method development as well as a client comparison of 3 methods. I went into some potentials for variability, and as far as webinar number 3, same time, same place, next Wednesday, May 28th at 10 a.m., I'm going to go into our ALS Siloxane Method 101, from collection to analysis, how ALS developed a quick and easy sorbent tube method for siloxane collection. I'm going to go into how our method works, the compound list and why we chose it, how to actually take a sample. Hopefully there will be a little video or I'll walk you through it, and then there will be a question and answer session to answer, any questions that I may have missed in these previous 2 webinars. So with that being said, thanks for your time, and I'll open it up for questions.
All right, Sam, great job. Another really great webinar, a lot of information, and I think hopefully everybody on the other end enjoys and takes this all in. I think it was a lot of information in a short period of time, so Like I said, we're going to open it up to some questions, so here we go. How do the methods compare in terms of repeatability, accuracy, and precision?
Well, that's a good question, and I mean, unless I was running 500 samples of each methodology, it would be hard for me to give you a very accurate answer. But as far as what we have seen with our client comparability analyses, when clients are using Kevlar bags and sorbent tubes, those have been extremely comparable. As far as, you know, the values that I reported to you in this presentation pretty much hold steadfast for most applications. The methodologies that didn't match still don't match, and the methods that do match, they do match. The impingers, the you know, the sorbent tubes, as far as the comparability, they're extremely comparable. So then it ends up leading to the question of what's easiest to sample, what's the most convenient operating strategy, and then ultimately what will give you the lowest reporting limits if you do happen to use a turbine or a microturbine that has low limits.
Okay. How can a canister not recover 100%? Is it rather the lab analysis that is at fault?
As far as the canister is concerned, the reason why we were getting poor recoveries really has to do with the molecular weight of the canister. We investigated the canister for a long time just because we primarily do canister analyses here, and we like cans. We know how to utilize them in a good fashion, and clients like cans too. They're easy and instantaneous. But ultimately, the can, we found that the siloxanes, especially as you got to the heavier compounds, they were harder to recover accurately out of the can. And I mean, we tried heating the can, we tried doing all sorts of things, but ultimately we ended up going with the sorbent tube because it was easier and it gave us better recovery. So it wasn't necessarily the analysis, but rather the collection device that strayed us away.
Do you have any recovery data using standards and different sampling media?
Yes, we have lots of information. So for whoever asked that question, if you just wanted to go ahead and drop an email to Edwin, and I can get some further data over to you.
Are you aware of any technologies that successfully remove siloxanes?
Oh yes, all sorts of stuff. I mean, if you think about a sorbent tube, it's kind of like a mini scrubber. So most scrubbing techniques, I'm not going to go too much into this, but many scrubber techniques utilize treated carbon beds or silica gel. You know, even condensation removes trimethylsilanol and D3 if you've got some kind of condenser. So it really depends on what kind of siloxane you're looking to remove, as well as you know, what kind of technologies you have at your fingertips and at your landfill.
Okay. How did you determine that there was a high bias in the
That is an excellent question, and I think that well, I can understand why you would ask that, and most of it really comes from anecdotal information. You know, I know a number of people in the industry who analyze for siloxanes. You might call them competitors, but ultimately we end up fighting the same battle with having a method online that doesn't necessarily have any regulatory oversight. But as far as the mineral oil analysis is concerned, it overestimates in all categories, and I think that it's considered to be overall categories when you have a CAT engine that has a limit of 0.6 micrograms per BTU and the mineral oil value is 6 times higher. It's 6 times higher. That would definitely cause engine failure or something. And the fact that they were not experiencing any issues and that they were outside of their warranty by being these high values, you know, it caused clients to question the values. And so that's how I came to the conclusion that I had come to.
Did either case study use a control sample of known siloxane concentration?
No, it did not, and that's why, because these are real-world samples. If we, you know, if we just injected a standard on there, the values would always look better. Because unfortunately, landfill gas is dirty, and so it causes a lot of problems analytically speaking. And it's easy for us to inject a standard and say, hey, we can do this, but it's another thing to go out and collect real-world samples and, you know, see how they compare.
Does EPA or pipelines taking gas from producers using different sampling methods allow correction factors, multipliers based on different sampling methods to normalize the values?
Okay. Does EPA or pipelines taking gas from producers using different sampling methods allow correction factors? That is not a question that I can necessarily answer. I guess they would have to actually know what their real values are, right? So, one methodology to another, and the values do differ, but always by the same percentage. And so they create their own correction factors. But no, I've never heard of the EPA coming out with any sort of correction values.
Were you able to spike any samples with known amounts of target siloxanes? If so, what were the recoveries?
We have done, I mean, as far as bringing a method online for the sorbent tube, and we'll go into the follow an extremely strict criteria as far as absorption efficiency studies are concerned. So we have done a number of samples and of work where we spike samples and test the recoveries. Now, we haven't done that with the other methodologies, and the reason being is because we eliminated them fairly early in the process for reasons that I've explained here. But stay tuned to next week, and we'll talk a little bit more about how we got to our method and what kind of standards we had spiked and everything.
Does ALS do the siloxane analysis from Tedlar bags as well as carbon tubes?
We do, yes. We ended up bringing on Tedlar bags. And that's really, I mean, most of our odor clients as well as our wastewater treatment plant clients, they really like Tedlar bags, and so we can analyze them out of Tedlar bags as well. But for landfill gas applications, considering that they don't have the necessity of hazardous shipping requirements, it's our primary sampling methodology.
Did your case study use heated canisters?
It did not, and we did investigate it. We do have a canister heating system, but ultimately we're a commercial lab, and so we don't have the capabilities of heating equally usable sorbent tube as well as Tedlar bag methodology.
Okay, have you determined whether there is a volatility in large difference in one test result to the other in Oregon?
Have you determined whether there is volatility in the? I think you're talking about variability in the concentration of siloxanes coming out of the landfill, and unfortunately, I don't personally know if there was variability, but they ended up taking a duplicate mineral oil sample in addition to the 2 Tedlar bags and the 2 sorbent tubes. So as far as the values are concerned, they were all fairly different, so I guess that would show a little variability, but I'm sorry, I don't necessarily have the answer to that question.
Okay, and I guess that's the last question that we received. Actually, there was one other question, and it was, could you receive a copy of the presentation? And Rivera at alsglobal.com. I will be happy to send over a PDF copy of that. And so with that, we'll look forward to seeing you guys next week. Thanks again for joining us, and talk to you soon. Thanks, Sam.
Bye.